Welcome to the DIY Honda Garage channel. Welcome to the diagnostic presentation for DTC P0335 titled CKP Sensor No Signal, specifically for the Honda HR-V models from 2016 to 2022. This diagnostic trouble code, DTC, indicates that the crankshaft position, CKP sensor, is not sending a signal to the powertrain control module, PCM. The CKP sensor plays a crucial role in determining the position and rotational speed of the crankshaft for engine timing. It's generally located near the crankshaft, often at the front of the engine, and connects to the vehicle's wiring harness. An absence of signal could lead to performance issues, including engine stalling, hard starting, or failure to start. Before performing any troubleshooting steps, it's essential to consult the general troubleshooting sections to understand the full context of this DTC. The CKP sensor, or crankshaft position sensor, is critical for monitoring the crankshaft's position and rotational speed, delivering essential information to the powertrain control module, PCM. This information is vital for precise ignition timing and fuel injection control. As mentioned, the sensor is typically situated at the front of the engine, near the crankshaft assembly. It connects to the vehicle's electrical system through a wiring harness. A malfunction in this sensor, particularly a complete loss of signal indicated by DTC P0335, can impede the engine's ability to determine its position. This can lead to serious operational issues, including poor fuel efficiency or inability to start the vehicle altogether. Understanding the possible causes of DTC P0335 is essential for effective troubleshooting. The first potential cause is an open circuit in the wiring connecting the crankshaft position sensor to the powertrain control module, which can prevent the signal from being transmitted. Another possibility is a faulty CKP sensor itself, which may be damaged or malfunctioning, leading to no signal being sent to the PCM. Lastly, the PCM may require an update or could itself be malfunctioning, which can result in failure to interpret the sensor signals correctly. All these factors must be considered when diagnosing the issue to reach an accurate conclusion. Symptoms associated with DTC P0335 can vary, but they primarily revolve around engine performance. One common symptom is that the engine may fail to start entirely. This is due to the absence of timing data from the CKP sensor, which is essential for the ignition system. Additionally, drivers may experience stalling while driving, which poses a significant safety hazard. Other symptoms may include erratic engine performance, such as misfires or reduced acceleration. Detecting these issues early is crucial for preventing further damage to the engine or other components, resulting in costly repairs. The first step in troubleshooting DTC P0335 is to verify the problem accurately. Begin by turning the vehicle to the on mode without starting the engine. Next, use the Honda Diagnostic System, HDS, to clear the current DTCs. After clearing the codes, start the engine and check for any pending or confirmed DTCs using HDS once again. If DTC P0335 reappears, it confirms that the failure is still present, and you should proceed to the next troubleshooting step. However, if it does not appear, it indicates an intermittent issue, requiring you to inspect for poor connections or loose terminals, specifically at both the CKP sensor and the PCM. In Step 2, you'll need to check for any open circuits in the wiring that connects the CKP sensor to the powertrain control module. Start by turning the vehicle to the off or lock mode. Disconnect the CKP sensor's 3P connector to facilitate the test. Once disconnected, turn the vehicle to the on mode and measure the voltage between specified test points. you'll be checking between CKP sensor 3P connector number 3 and body ground. If you measure battery voltage, this indicates that the wiring leading to the sensor is intact, and you can confidently move on to step 3. However, if there is no battery voltage, it indicates an open circuit that must be repaired. The third troubleshooting step involves determining the possible failure area by measuring the voltage between two specific test points. With the CKP sensor 3P connector still disconnected and the vehicle in on mode, you'll measure the voltage at CKP sensor 3P connector number 1 and compare it with body ground. You're looking for approximately 5.0 V, which signifies that the wiring from the PCM to the CKP sensor is functioning correctly. If you detect this voltage, proceed to step 4 for further assessment. Conversely, if the voltage is not at the expected level, you'll transition to step 5, as it may indicate an issue with one of the wires. Here in step 4, you will conduct another open wire check to examine the LG line specifically. This involves measuring the voltage between CKP sensor 3P connector number 2 and number 3. With the 3P connector still disconnected and the vehicle set to on mode, ensure to check the terminals on the female CKP sensor connector closely. If battery voltage is detected at these points, it indicates that the LG wire connection is intact, and you now need to replace the CKP sensor as the problem is likely due to its failure. However, if no battery voltage is present, you'll need to repair the LG wire between the CKP sensor and G101. Step 5 requires a shorted wire check, specifically on the crank line. Begin by turning the vehicle to the off mode. Once off, use the HDS to jump the SCS line for testing purposes. Disconnect the PCM connector B, ensuring that it is not connected during your test. From there, you will check for continuity between the defined test points, ensuring that there's appropriate connectivity between PCM connector B, 51P, number 11, and body ground. If continuity is present, the crank wire may be shorted and you will need to repair that short circuit. If continuity is absent, it indicates that there is no short and you should proceed to the next troubleshooting step. The final troubleshooting step involves another open wire check on the crank line. To start, jump the CKP sensor connector terminals A and B directly to body ground. This action allows you to test for continuity between the points of PCM connector B, 51P, number 11, and body ground. After establishing connections and turning the vehicle to the off mode, measure continuity between the test points. If continuity is confirmed, this suggests that the crank wire is functioning correctly. In this case, you will need to either update the PCM software if it is outdated, or substitute it with a known good PCM. If replacing or updating resolves the DTC P0335, your troubleshooting is complete. If not, and the DTC still appears, it would imply that the original PCM should be replaced. After executing the necessary repairs or replacements, it's vital to verify that the repairs have indeed worked. Start by clearing the DTC using HDS once more. Following this, start the engine and monitor the system to ensure that no fault codes reappear. This confirmation step is crucial, as it ensures that the issues causing the DTC P0335 have been adequately addressed. If no codes return and the engine operates smoothly, you can proceed with confidence that the repairs were successful. If DTC P0335 reoccurs, revisit the troubleshooting steps to ensure that no faults were missed. While troubleshooting helps resolve immediate issues, preventive maintenance is vital to avoid future occurrences of DTC P0335. Regularly inspecting the CKP sensor for signs of wear or damage can preempt problems. It's also essential to check the wiring harness for integrity, looking for frays or environmental damage that may affect connections. Moreover, ensure that the PCM software is always updated to its latest version, as software bugs can sometimes lead to erroneous codes, including P0335. Implementing these practices can ultimately improve vehicle reliability and performance for the long term. In conclusion, DTC P0335, indicating a CKP sensor no signal, involves understanding the core function of the crankshaft position sensor, as well as detailed troubleshooting procedures. It's crucial to methodically follow each step outlined in the diagnostic guide to accurately identify and resolve the issue. By conducting proper diagnostics, remedies can prevent further complications, enhancing the reliability and performance of the Honda HR-V. Also, incorporating preventive maintenance strategies ensures that current issues remain resolved and bolsters long-term vehicle dependability. Thank you for your attention, and I hope this presentation aids in effectively addressing any concerns regarding DTC P0335. Please like and subscribe to the channel. See you next time.